Hello everyone, myself Mr. Uttam Gowdi, Assistant Professor in Mathematics, Rayat Shikshan Samsthas, R.B. Narendra Boruga College, Srampur. Here, today we will discuss a topic, divisibility. First, we will see the definition of divisibility. If a integer b is said to be divisible by a non-zero integer a if there exists an integer, say x, such that b is equal to ax, and we write a divides b. In case there does not exist an integer a, we say that a does not divide b. In case if there does not exist such x, then we say that a does not divide b. Here we will see some properties on definition of divisibility. Here, property number first, if a divides b, then there exists, then a divides bc for any integer c. Now here we will see here proof. Now proof, given a divides b and a, b and c belongs to z. Now by definition of divisibility, there exists integer x such that b is equal to ax. Say equation number first. Now multiply equation 1 by c. Multiply equation 1 by c, we get b into c is equal to a into x into c. Now here we write this equation as b into c is equal to a into x into c, that is a into q, where q is equal to x into c. Here x is also integer, c is also integer, so multiplication of x into c is also integer, that is q belongs to z. Here we will prove bc is equal to a into q, and by definition of divisibility, if we remove q, then it can be written as a divides bc. Now second property, if a divides b and b divides c, then a divides c. Now proof, given a divides b and b divides c for a, b and c belongs to z. Now by definition of divisibility, there exists integers, say q1 and q2 such that b is equal to a into q1, say equation number first, and c is equal to b into q2, say equation number second. Now put value of equation 1 in equation 2. Put equation 1 in equation 2, we get c is equal to a into q1 into q2, and we rewrite this as a into q, where q is equal to q1 into q2. Here q1 is integer, q2 is integer, so q1 into q2 is also integer. That is, q is equal to q1 into q2 belongs to z, and here we will prove c is equal to a into q, and by definition of divisibility, if we remove that q, then it can be written as a divides c. Now here the property third, if a divides b and a divides c, then a divides bx plus cy for any integer x and y. Here we will see. Now prove. Given a divides b and a divides c for x, y, a, b and c all are belongs to z. Now by definition of divisibility, there exists, say q1 and q2 belongs to z such that b is equal to a into q1 and c is equal to a into q2. Say equation number b is equal to a into q2, say equation number first, and c is equal to a into q2, say equation number second. Now multiply equation 1 by x and multiply equation 2 by y. We get bx is equal to a into q1 into x, say equation number 3, and c into y is equal to a into q2 into y, say equation number 4. Now add equation 3 and equation 4, we get bx plus cy is equal to a into q1 into x plus a into q2 into y. Here right side of these two terms is common, so multiply a into q1 into x plus q2 into y. That is, bx plus cy is equal to a into q1 into x plus q2 into y, and this equation can be written as bx plus cy is equal to a into q, where q is equal to q1 into x plus q2 into y, and here x and y are given integer and also q1 and q2 is integer, so q is equal to q1 into x plus q2 into y belongs to z. Now here bx plus cy is equal to a into q, where q is equal to q1 into x plus q2 into y belongs to z, and we remove the integer q. It can be written as a divides bx plus cy for x and y belongs to z. Now property number 4. Now property number 4, if a divides b and b is not equal to 0, then absolute value of a is less than or equal to absolute value of b. Here proof: given a divides b and b is not equal to 0 for small a and small b belongs to z. Now by definition of divisibility, there exists, say q belongs to z such that b is equal to a into q. Say equation number 1. Now here given b is not equal to 0 implies a into q is not equal to 0, that is q is not equal to 0 and q belongs to z. So q is greater than or equal to 1 implies absolute value of q is greater than or equal to 1. Now by equation 1, absolute value of b is equal to absolute value of a into q is equal to absolute value of a into absolute value of q, but absolute value of q is greater than or equal to 1. Now multiply both sides by absolute value of a. Multiply absolute value of a, we get absolute value of a into absolute value of q is greater than or equal to absolute value of a, and this implies absolute value of a is less than or equal to absolute value of a into absolute value of q is equal to absolute value of b, hence the proof. Now here property number 5. If a divides b and b divides a, then a is equal to plus or minus b. Now proof: given a divides b and b divides a for a and b belongs to z. Now by definition of divisibility, there exists, say q1 and q2 belongs to z such that b is equal to a into q1, say equation number 1, and a is equal to b into q2, say equation number 2. Put value of equation 1 in equation 2. Put equation 1 in equation 2, we get a is equal to a into q1 into q2. This implies a is equal to a into Q1 into Q2, but A is not equal to 0, so divide both sides by equation 1. We get 1 is equal to Q1 into Q2, and Q1 and Q2 both are belongs to Z. This implies either Q1 is equal to 1 and Q2 is equal to 1, or Q1 is equal to -1 and Q2 is equal to -1. If Q1 is equal to 1 and Q2 is equal to 1, then A is equal to B, and if Q1 is equal to -1 and Q2 is equal to -1, then A is equal to -B. Now here we prove either A is equal to B or A is equal to -B. Now hence A is equal to plus or minus B.